Right, hello and welcome back. It's got to be about 6 months now since I last did any work on this engine and posted a video of it. If you haven't seen any of these, just click on videos on my channel and go back and you'll see that it starts with me buying this thing off Facebook and subsequently finding out some history on it really interestingly and just building it up a section or a sub-assembly at a time, and just been lots of other work on. Not been able to get on to working on it. So this time I'm going to assemble the propeller reduction gear, just to explain a little bit about what the parts are that go into it. It's quite a simple gearbox, but it also has a hell of a lot of work to do, quite a lot of loading on it, and assemble it onto the engine. Okay, so in brief, the reduction gear consists of an aluminium casing which matches the front of the crankcase. The gears, which you can see here, on this particular engine they have a 0.42 reduction ratio, and that's because with the diameter of the propeller, to get the most efficiency, you don't want the tips of the propeller to go supersonic, because then you just lose a lot of efficiency. So the propeller has to be geared down, which is quite common on a lot of engines, even a lot smaller than these, and it's just a basic spur gear. And there's quite a lot of backlash between these gears, and it's sort of in some respects you might think it's fairly agricultural, but of course, as we know already, they knew an awful lot back in the day when they designed these things. The two gears each run on a pair of roller bearings primarily, so there's one at the back of the main shaft there, and we'll see as it's assembled. There's one goes in the front here, there's one on the back of the pinion which is driven by the crankshaft, and there's another one that runs on the front. And it's not able to shuttle backwards and forwards because this is the roller bearing that goes on the front of the pinion. It goes up against a step, and there is a front hardened disc that goes there, and then it's all held on with a nut. So that actually means that the rollers will take a certain amount of thrust loading as well. So the main bearings for the prop shaft go into this housing, and then onto the front of the housing there is a front cap, and inside that is an oil seal, which will be just the same as the principle as the oil seal on the back of an engine, where you have the flywheel or the flex plate to keep the oil in. But this gearbox is actually part of the crankcase, so oil and air can travel through there back into the crankcase, and there's an oil jet from a low pressure oil supply here, and there's also another one in the side of the reduction gear casing, so there are two, and they fire oil there and there onto, actually into the point where the two gears mesh. But one thing that's quite important on these kind of gearboxes is you don't want it running in oil, you don't want a level of oil here, because it causes a lot of drag. So they have the bare minimum amount of oil to lubricate the meshing point of the gears, and no more than that, and then the rest of it will all drain back, and you can actually probably see some holes here around the periphery of this roller bearing outer race where it drains back into the sump or the lower crankcase. There's one other feature of note on here, which is that there is an oil feed for the hydraulic propeller, because most of the propellers on these, the pitch is controlled by engine oil pressure. And this spigot on the back of the main prop shaft goes into a set of seals in the crankcase there, and you've got your incoming oil on the outside of it. I think it's the other way around actually. The incoming oil down the middle, the return oil around the outside of it, running on spring-loaded seals inside the crankcase. Are you going to stay there? No. Yes, right. So the first thing we're going to do is assemble the bearings into the housing. We'll move this out of the way for a minute. So I said that the shaft runs on a pair of roller bearings, and this is the front roller bearing, quite a chunky affair. But behind that, in the back of the casing, is the thrust bearing, because although I said with the pinion the side races of the roller bearing are sufficient to take the thrust. Obviously there's no way you can imagine an aircraft, even a single engined aircraft that weighs quite a few tons, climbing vertically. There's all the weight of the aircraft on the back of it, and everything, all the thrust of the engine is taken by this ball thrust bearing, which actually has a two-part outer race, and then that goes into the housing first. So this sits in the middle between the two roller bearings. So we're going to drop that in first, and in fact I'm going to oil it. And the outer race can go in. Now, between the two bearings on both the outer and inner races, we have these bronze components which allow oil to pass through the bearings. Again, you don't want these bearings to be completely jam-packed full of oil, because it causes, again, a lot of drag and you lose power, and it's unnecessary, and it produces heat as well. So I've got that in there. In the middle, again, this has oil lubrication grooves on it on both sides, so this component goes in the middle. Then the roller bearing, which again I'm going to lubricate on. That just drops in there. Supposedly. Just take that out from there. So the thrust bearing is a very loose fit in the housing, because you don't necessarily want to locate the outer races radially. It's a thrust bearing, it just operates backwards and forwards effectively. This one is a much closer fit in the housing, but again, it's not particularly tight. They're very tight on the actual prop shaft, but not in the housing. Okay, so I did have to admit defeat and press that in the last bit, right. So the inner race of the roller bearing is going to go in, and we need to make sure that still turns nice and freely, which is great. Right, so now I'm ready to put this bearing assembly into the front casing. You can see on the top lug there, it's got the engine number stamped on it, so we always know which way around it goes. These bolts are asymmetrically spaced, so it only goes on one way, but it can be a bit of a faff actually finding which way it is. So, and I've put sealant on the back of this thing before I put it on. The later versions of this used an O-ring under there. Again, this is quite an early engine, and as you can imagine, oil leaks were always a bit of a battle for them anyway. So that's on that. There it is, somewhere. Right, a spacer, which is selected to go on the front of here to put compression onto the two bearing outer races and the centre component, because they're meant to be nipped in place, and if not they will have a tendency to rotate in the housing, potentially, not necessarily. Now I'm going to fit the front cover stroke seal housing. Goes on there, like that. And what I'm going to do is, see that spigot's into the outer casing, so it's quite a close fit to keep everything centred. And I'm going to put some nuts on it to hold it in position. This is just a temporary fit. When it's finally put on, it actually has tab locking washers, which is what these holes are for, next to the studs. And I just want to hold this thing together for now, while we're fitting the shaft. Now the front roller bearing, which sits in here, runs in a sleeve. And I was watching quite an interesting video, probably watched too much YouTube to be honest, the other day on my lunch break, with a company who were looking at EV car transmissions, electric cars. And they still have a lot of problems with bearings that are fitted into aluminium casings, which is quite common, particularly in gearbox. I mean, everything, all the casings for engines are now made of aluminium. And the bearings rotating in the housing and effectively eventually wearing it away. Because aluminium expands quite a lot, and it certainly expands more than steel. So the various different ways to go about stopping this are, on the Merlin, they use a steel outer sleeve, and you can play about a bit more with your interference fits. You can specify sleeves of different thicknesses, and this pushes onto the bearing quite easily. But actually, when the whole assembly is pushed into there, it then becomes tighter. That helps. This is held in simply by the nip placed on this front flange of the housing, which you'll see later, which bolts onto here. They did have problems with the bearings turning in the engine, and in some places on the Merlin they actually put a flange onto the outside diameter of some of these bearings. In fact, this is one of them on the very late engines that were used on civil aviation, sort of aircraft like the Argonaut and the Avro Tudor. This was then bolted in. It just makes the bearing a hell of a lot more work to manufacture because it's a lot bigger. It's got obviously a PCD of holes around the edge of it, but that completely stops it from ever rotating in the housing, and that is virtually the only way to really do that. Tesla, interestingly enough, on their transmission, they put something like, I can't remember exactly what it was, but basically some kind of pin, I think it is, just into the bearing housing, but in one position, which would prevent it from rotating, definitely. But I am wondering whether, as it starts to, if the aluminium expands and the bearing is no longer tight enough in the housing, it's still going to want to vibrate, and it frets, and when it frets, that is basically eating away at the aluminium, and the bearing then becomes loose. So it'll be interesting to see in the longer term if solutions like that do actually work. But they have to think about it today just like they did back then. So that's the steel sleeve in there, and again, fits quite freely into the housing. It's not really tight, but when this bearing is pushed in, it'll be quite a tight fit. Okay, so we're now going to lower the housing over the prop shaft. I'm just going to oil the bearing germ diameters on here. And also the retaining thread. There. And then grab the housing. Now, this casing, because I don't have a workshop, so I'm not doing these things commercially anymore, I don't have a big enough press to get this into. This casing is actually, it's only 20mm wider than the press that I've got in here, so anyway, it won't go in. So this is the tool that would normally go in the press. Goes over there, and then basically you can press the bearings down onto the shaft. However, I'm going to use a block of hardwood and a hammer, and then once it's part way on, I'm going to finish the job off with the retaining nut. reckon that's got it. There we go, that's almost all the way on in one hit. You could also use an induction heater on these. The only problem is they're already in the housing, so quite as simple as that really. There's a thrust plate which I'm going to put on and oil it. Just for the nut to run against, so we're not throwing the nut up against the bearing itself. And then I'm going to take a lot off again because there's a tab washer. This is unusual, I think this is unique on the Merlin, as far as I can remember anyway. When you get a left-hand threaded component on the Merlin, they always put the word off and they put an arrow. This is the only one I know of on the Merlin which is a right-hand thread, and it actually tells you which way to unscrew it. I don't quite know why they did that, because the convention normally is that if it says on it which way you undo it, then it's a left-hand thread. So, interesting that. I don't know why. But, go. Basically, I'll just do it that way until the thing's fully screwed on. Looks like it. Yep, that's got that. So, do these up, then this is a component that runs inside the oil seal, which is just pushed on afterwards. Oil this. And also obviously oil the face that's running on the oil seal. It's interesting actually how you can see the line where the oil seal's been running on there, and these rubber oil seals, you see it on engines quite a lot. Even though this surface has been hardened, they still eat away into the metal. So then we'll put the oil seal back on. And again, I'm just going to temporarily retain it with these. Four nuts. So the pinion just feeds in to the front roller bearing from the back. Being careful not to get my fingers in between the gears here, so that at the moment that all feels fine. I'm going to put the retaining nut and plate onto this thing, so I'm going to put a bit more oil on it first. Now this is the front thrust plate. And then we have this tab washer. This goes on there, and then an upright on top of the tab washer. So I'm going to put a bit of oil on it. So I'm going to be doing it up on there against it. Now this is the one which is left-hand threaded. Naturally, because of the direction of rotation. So the propeller on this engine goes that way, anti-clockwise looking onto it. So the front of this pinion goes clockwise. And so the way to work out whether a thread should be left or right-handed on a rotating piece of equipment is that if it's running and you've grabbed hold of it, theoretically, it should tighten. So it's running that way, I grab hold of it, it's going to tighten, it's going to effectively try and go that way, which is correct. So that's the reason we use the left-hand thread. They don't do it all the way through the engine. Some of the threads are right-handed, even though in theory they shouldn't be. But generally speaking, particularly on the highly stressed components, they'll always hand the threads. So this is a point where years and years ago I used to just pick this thing up and stick it on the front of the engine, and that's probably part of the reason why I had a bad back, or have a bad back. Now the coupling shaft, this pinion is driven from a spline inside the engine, so that's the end of the crankshaft, fits over that. This goes into the pinion, and this is a hollow quill shaft, which, believe it or not, even though it's probably about, the wall thickness is about 10mm or 3/8 of an inch, this does actually twist. And this, in conjunction with a much smaller shaft driving the supercharger and various gears on the back of the engine, do a similar job as a crankshaft damper. And there is no crankshaft damper on this, and certainly straight six engines and V12s will always generally have one, but I mean aero engines never do anyway. So this goes into the engine. In fact I'll probably put it into the back of here first. We're going to put this thing up on the crane, offer it up to the engine, just temporarily nip it up with a few nuts. Then we're going to lock the crankshaft and finally tighten this. When I used to do these commercially, these just used to go onto a jig and we'd do all that, but it's a matter of space really in here. Just haven't got room for all the gear anymore. Right, that's just got it on far enough to put a 3/8 nut on two of these studs. I'll very carefully wind it in. I can't just wrench it up because, for example, the spline driving through the centre here might not be in alignment, and I might actually have to rotate the gears to get that to go. So just very, very carefully pull it up. So this is the shaft coupling we used to use on the dynamometer when we were testing these engines. There we go. Still just touching, so that feels like it's about right there. Yeah, that's going in now. So at this point I shouldn't be able to turn this, or at least it should turn the crankshaft anyway. There you go. So that's coupled up now. I'm going to push it on a bit further. So that leads me on to something else, talking about the dynamometer, which I haven't touched on yet. The torque output from the crankshaft, depending on the version of the engine, is somewhere in the region of 3,000 foot-pounds of torque. By the time it's reduced down, certainly on the most powerful Merlins, the output torque on this shaft here is about 5,500 foot-pounds. There's an awful lot of load on this gearbox, especially considering it's a relatively light aluminium casting. So I'm now going to lock up the crankshaft to stop it from turning. Right, so just trying to work out how to get 1,000 pounds-feet on this thing. So there we go. Well, it's moving. No, that's not happening, is it? Right, okay. Need to call on the enforcer. Right. Let's have a go with this. There we go. Now, obviously, because this thing isn't going back in the air, if it's getting near the tab washer, which has multiple positions, it's like a vernier washer, I'm going to lock it up before it reaches 1,000 because I don't want to go over it. It's almost there, actually. That's it. I think that's it. Yeah, it's bang on. Obviously, any more force than that, I'd have to put a big piece of steel underneath here across the floor because it was going to tip the engine over, but that's now tightened up. So the final piece of the puzzle for the reduction gear, at least, is going to be this dual drive casing which fits on the front there. And the propeller CSU, which is the governor that controls the pitch of the blades, goes on one side of it, and the vacuum pump on the other side, which is used for gyroscopic instruments in the cockpit. Now, this is driven by this little quill shaft here, which goes in the front. So I'm going to remove this component, one that goes into the engine. I'm then going to insert this first, followed by that, and then I can pop the gearbox back on the engine. I'm also going to lubricate those gear teeth as well. So this is the dual drive, or V drive as it's known, quill shaft installed in position. This is the centre shaft that it goes into like that, and there's a bevel gear there. This is the shaft which drives the vacuum pump, goes there, and similarly this is the adapter for the propeller CSU or governor, goes there. In order to set the backlash in the gears, there are shim plates that go on to the casing like that, and that's basically it. One more observation before I put this thing back together. This gear and the flange, which is incorporated with the shaft itself, are two separate components. This is partly because they ran different ratios in these engines. Spitfires ran a 0.477 to 1 gear. This one, as I mentioned before, is a 0.42. Packard also had a couple of other ratios. But also, it's a very large single component, and a mistake on it means scrapping the whole part. So this is probably part of the reason as well why they were separate. It's forged as well, so even though the shaft is a lot smaller than the flange, it's not like it was machined out of a solid billet of steel. It is actually forged into this shape and then rough forged and then machined. So these bolts are a very close fitting taper, and they're stretched when they're tightened up, so they're extremely tightly fitting when they're done up. They doubled the number of bolts on later engines as the power went up, in fact, as well. So there we have it. I hope you enjoyed this episode. I'm going to put all the bolts back in, tighten everything up, actually reassemble the V-drive. I did notice that the prop shaft oil seal has shrunk, because it is the original one off the engine, and there's a gap around it, so I'm actually going to take this housing off. And that gets me around to the point of how original this thing is. It really is a bit of a time capsule in a way, but in this reduction gear I did actually change the ball and roller bearing in here on the basis that it's actually had water sitting in it in places. It was upside down for most of its life. I just wasn't 100% happy with the condition of those. All the other roller bearings on it were okay. Bearing in mind the fact that you've got like a 200 kilogram propeller hanging off this thing, even if you're just running it on the ground, which is what this thing potentially do. So I've changed those just out of precaution really. I think overall almost 100% of this engine is going to be original when it's finished. So in the next episode I'm going to be assembling the wheel case, which goes on the other end of the engine there, drives all the gears, has a supercharger drive inside it, so there's quite a lot of components in that, but I'm on with cleaning it up now, so hopefully before too long we'll have another episode.